null point means the electric field will be zero, isn't it? But whatever D we are getting over here, we will have to still verify. Like even I asked many persons today that why it is appearing like this, but means this is just coming graphically that minimum it is over here, right? Or not. But the null point is not over there at minus d by 2. Is that clear? Yeah, so there is no null point at minus d by 2. It's a minimum electric field. Why we are saying minimum electric field? Because sometimes what is happening, we are suddenly changing from plus q to minus q. So that is why they are saying that this is a point of minimum electric field. Are you able to get me or not? The null point is at infinity over here. It's not at nearby any charge. Yeah, I mean, it's not at finite distance. So one thing we are getting at infinity now. That's why we are calling it as that it is present at infinite distance. Are you able to get me? Okay. Okay. So today we are going to understand one of the most important topic, and then I'll start mixing the topics. And today's topic is electric field lines. So give the heading electric field lines. That's what we are going to start right now, and then we'll move ahead. Okay. Take. Sure. So let us talk about this. So first concept which comes to our mind, that what is this electric field lines, isn't it? That's a big question to understand, to verify, to cross check. All other things are there in that, isn't it? Now many people says that electric field lines is something which is present as field lines or properties of charge or something like that. But actually, our electric field lines has a very specific meaning, and that's what we are going to define today. Are you able to get me on? Okay. So first thing, let's suppose if I have any charge, okay, if I have any positive charge, then for any positive charge, the electric field at any point is given as how much? Simple, just like yesterday. If this point is located at a distance r, then this electric field was given as 1 by 4 pi epsilon naught q by r square. Now, next point, I'll keep this as 50. Yeah. Next point, that for any positive charge, the electric field lines or electric field points away from the charge, isn't it? And for negative charge, yeah, for negative charge, the electric field lines is towards the charge. The electric field is directed towards the charge. अब देखो ध्यान से समझना जरा, what we are going to discuss right now. See, in whole of your total physics, like in last year we had a term that in we learned in fluid mechanics, that there is something called as streamline flow, isn't it? And what we told about streamline flow, that it is nothing but it is a particular kind of a line which a particles are following to move inside the fluid, isn't it? Yes. And at every point, if we just generate these tangents and if we connect these tangents, whatever line we were getting, we call that as streamline, which were the particles or which was the liquid that was following so as to travel, isn't it? This was our concept. Now, this whole concept is brought once again to the concept of electric field. See how? What is this electric field lines? Okay. So simple. It represents, I'll just write the properties of electric field lines first, then I'll move to the main conclusion. Okay. So what does it represent? It represents the electric field, or sorry, it represents the direction of electric field. Okay. direction of electric field at any point. So first thing, just like in streamline flow, at any point we can understand about the velocity of the flow. Similarly over here, for electric field lines, they just represent at any point what is the value of amount of electric field which is present at any point. Are you able to get me or not? Second thing, these are hypothetical lines. They are not in real. Yeah, basically they are just theoretical concept. It is not in reality. Just like magnetic field have lines, in reality, the electric field lines are not in real. Are you able to get me or not? Magnetic field lines are real over there, but the electric field lines are not real. That's just an hypothetical situation which we are considering right now. Is that clear or not? Okay. Next thing, just like in streamline flow, the tangent used to give the direction. Similarly over here, tangent at any point or tangent drawn on electric field lines gives us the direction of net electric field at that point. ठीक है? Is that clear? Moving to next point. Basically, these field lines are always continuous in nature. So we have four properties right now. Now these were mainly the direct properties. Now we have indirect conclusions regarding that. Now as we know that tangent gives us the direction of electric field, and at any random point two tangents cannot be drawn. That is why two field lines will never intersect each other. Are you able to get me or not? No, they can be parallel, but they will never intersect. Okay, they can be parallel. They can have any gap whatsoever is possible, but they will never ever intersect. Why? Because two tangent at any point is not possible. Is that clear or not? Remember this statement. Because in a certain reason they ask you, because there cannot be two directions of a tangents at any point. Is that clear or not? Are you able to get me? Next point. This is the most important one. And what does it says? Understand that. That since electric field or electric force is conservative in nature. किस तरह का नेचर है? Since the electric force is conservative in nature, these electric field lines never forms a closed loop. अच्छा, इसके पीछे रीजन क्या है? अब समझना जरा कि why does the electric field lines are never ever going to form a closed loop? Although these electric forces are conservative in nature, the reason for that is simple. That we know that in a closed loop, the work done is always zero or not. But actually, when I'm moving a charge in a closed loop, it's never ever zero. It is always some kind of energy is required to move this charge. So that is why it is necessary to understand that electric field lines should not form a closed loop, because we know that the work done will become how much? Zero. And if work done is zero, no charge can be carried here and there. Are you able to get me or not? So the point is simple. The electric force is conservative in nature. You should never ever form a closed loop with the electric field lines. Are you able to get me or not? Next point. Let us understand that more closer the electric field lines, this implies more is the electric field strength. more is the electric field strength. Are you able to get me or not? Are you able to get me? Okay. Now, next point, let us understand that. And this is the last important point, that electric field lines originates from positive charge and terminates at a negative charge, or at infinity. Means अगर मान लो पॉजिटिव चार्ज के सामने नेगेटिव चार्ज नहीं, then this electric field lines will never ever converge over there. It will definitely end up where? It will end up at infinity. Is that clear or not? The last most point, that number of electric field lines for a given charge tells us about the magnitude of electric field strength of that charge. ठीक, द अमाउंट ऑफ, जैसे मान लो एक चार्ज है Q, इसके ऊपर से मान लो 5 इलेक्ट्रिक फील्ड लाइंस निकल रहा है, कितने, हाउ मेनी इलेक्ट्रिक फील्ड्स आर ओरिजिनेटिंग फ्रॉम इट, लेट्स सपोज 6, राइट और नॉट, and then there is another charge from which there are 8 electric field lines which are originating, right or not? I think 8. So then the magnitude of this charge is more as compared to the magnitude of this charge. Are you able to get me or not? Yeah, because of presence of more field lines. So remember that more is the field lines, more is the electric field strength of that particular respective charge over there. Is that clear or not? Is that perfectly clear? मेरी बातें समझ में आ रही हैं? Confirm हो? Okay. So right now we are going to have a discussion regarding same only, and we will focus on some more important conclusions. Okay. And 1 minute. Let me just uh, 1 minute. Let me just share the video. I didn't share it on my WhatsApp profile. Yeah. Okay. Now I have shared. 1 minute. Yeah. Okay. Now, till now, any kind of doubt do you have? No. Okay. So now look over here. Let us see. Let us understand. So let's suppose if I have a positive charge and if I have a negative charge. Okay. So for a positive charge, let's suppose this is positive plus Q and this is minus Q. For a positive charge, the electric field lines are radially outward. Okay. They are totally radially outwards. For negative charge, they are radially inwards. Good. For negative charge, they are radially inwards. Is that clear? For this, it is radially outwards. For this, it is radially inwards. Is that clear or not? Okay. So let us just have a understanding Now, these were two independent charges, two independent positive and negative charges. What happens if I have a pair of charges? That's a big question, and that's a better way to understand. Okay, so let's suppose if I have a positive charge and a negative charge. Okay, first we'll consider 1 minute. Let us control C, control V, control C, control V, control V, control C, control V. Okay, let me just distribute this. So first I will have two positive charges. Got it? I have two similar positive charges. Got it or not? Okay. So let's suppose this is plus Q and this is also plus Q. Same amount of charges are there. Okay. So then where will be the electric field lines? What will be the representation of electric field lines? That's a big question, isn't it? We know that. Yeah. So what will happen? For this, the electric field lines will start emerging outwards. Now, the point is simple. They start to become curved because of the presence of another charge and because of the presence of a repulsive force over there. Are you able to get me or not? Okay. What you are going to observe that these field lines are emerging, but they are in which kind of nature? Repulsive in nature. And that's why they become curved. Okay. Are you able to get me or not? So this happens for two pairs of similar charges which are positive in nature. Now let us consider what happens if I have pair of negative charges, similar negative charges. Then what will happen? If I have a pair of minus q and minus q, then what will happen? Can you tell me? Okay, so what will happen? The arrows will be pointing towards the charges. That means the arrows will start appearing like this way because of repulsion. Repulsion is still there, isn't it? So that is why we can see that the field lines are diverging actually, isn't it? Oh, sorry. I'll draw the lines first, then I'll draw the arrow. Okay. But these arrows will have one thing in common, that these field lines will be appearing to be converging towards the charge itself, but in which direction? Diverging way, such that they can show that there is a repulsion between two negative charges also. Are you able to get me or not? But now let's suppose if I have a, a combination of a positive charge and a negative charge. Let's suppose if I have a combination of a positive charge and a negative charge, if this is plus q and this is minus q, then what will happen about the field direction? Then what will happen about the electric field lines? So what you are going to observe that for positive charges, it will definitely come out, isn't it? And then suddenly, due to the presence of negative charge, these field lines will start, yeah, it will start originating from plus q, and it will start terminating on minus q. What? They are not cancelling, they are terminating, means they are entering at the negative charge. Okay, yeah, terminating means they are not getting cancelled out, they are just entering into negative charge. Okay, means they are becoming invisible towards negative charge. Right. Is that clear or not? But yeah, this is very professional, this is very good. But I ask you one most important thing, that let us just have a slight disagreement in such a way that I have a bigger charge and a smaller charge. Let's suppose this is this time plus 2q and this is this time just minus q. Then what kind of filled lines will be drawn over here? Can you tell me that? You think what will happen? I do not know. Think what kind of diagram will be there if the charge is one is plus 2q and another charge is just minus q? You will see that there are more field lines are there for plus 2q. Right or not? And some of them even are actually not even trying to enter into minus q. Yeah, because minus q can attract only a limited amount of charges, limited amount of field lines. Okay, a very limited amount is getting attracted towards minus q. Others are just going in space. Are you able to get me or not? Is that clear? And on minus q, very less amount of electric field lines will be seen as concentrating or converging on minus q. Are you able to get me or not? Is that clear? Okay, let's take one more example. Let's suppose, no, means let's have a total different case. Let's suppose if I have a triangle, okay, on and on this triangle, I placed on each vertices a positive charge. What I placed? A positive charge on each of these vertices. Then please try to draw the electric field lines of these charges. Try to draw it. Do it. Try to do it, guys, on YouTube also. Then I'll share you the solution. If all the charges are positive in nature, then draw the field lines for this triangle case. बताओ क्या होगा आंसर जल्दी. चलो अब ध्यान से देखो कैसे होगा. तो पहली बात कि सिंपल सी बात है, द फील्ड लाइंस विल इमर्ज, इजंट इट? These field lines will definitely emerge. Okay. And since all are positive in nature, what you are going to observe that these field lines itself in between, they create a gap in between them, and that is itself like looking like a सर्कल. किस तरह का दिखाई पड़ेगा वो? सर्कल की तरह. Are you able to get me or not? It will be visible like this way, that these field lines are originating from each charge, and वो said actually हाँ correct correct. These field lines are originating from each charge and they are creating a gap in between them, which is a circle. But this is not a closed loop. Remember that this circle is not a closed. This is just for an identification. That's why I have marked with a dotted sign. Why or not? It's not a closed, because if it is a closed, that means it is not a field lines, because the electric field lines cannot be always closed. Look over there. Right now we have said that electric field lines, they cannot form a closed loop. Are you able to get me or not? So this is why they do not form a closed loop, but definitely they create an interior circle between them, which is just located at some distance away from the centroid of the triangle. Are you able to get me or not? Is that clear? Okay. So these were the properties of electric field lines. But actually, what is the reality of why these electric field lines are brought? We'll talk about that. The most important fundamental principle is that the electric field lines travels with the speed of light. Now this is a nice thing which you got right now. What is the speed of electric field lines? Yeah, means it is always, every time electric field lines is always going to be moving with a what pace? With a pace of speed of light. Are you able to get me or not? Whether it is even the electric field lines, even for those lines, even for those lines, even for those lines in gravitational and magnetic field. Word or not? That first property is this only, that our electric field lines, out of conclusion, travels with the speed of light. They never ever get slowed down. Word or not? Whenever electric field lines will appear, they always travels with the speed of light. Is that clear or not? मेरी बातें समझ में आ रही है? अच्छा लगा सुन के? ठीक. दूसरी बात ये है कि many people think that when I release a charge, when a charge is released in exterior electric field, then we think that this charge will follow the electric field lines, isn't it? But actually, the charge, whenever a charge is released in exterior field lines, they do not follow. They do not. They do not necessarily follow electric field lines. They do not necessarily follow that particles should move along electric field lines. Okay, electric field lines just represent you the amount of electric field present in any direction. Is that clear or not? Are you able to get me? Okay, now next point is that, remember that how to categorize whether there is uniform electric field or something. So whenever the electric field lines are parallel in nature, okay, that means if I take any two random points A and B, then electric field at A is exactly similar to electric field at B. That means two, if the electric field lines are parallel, that means this represents an uniform electric field. What does it represents? Are you able to get me or not? Next point, let's suppose if I have the electric field lines in this fashion. This is point A, this is point B. So then the electric field at A means more closer. We know that more closer is the electric field, more is the strength of electric field basically, isn't it? Yeah, so E of A is more than E of B, and this represents every time whenever you have these kind of field lines, you should remember that these are representations of non-uniform electric field. Is that clear or not? Are you able to get me? But then these were basically, we can see that they are kind of diverging or converging, isn't it? But I'll tell you one thing. Many people ask you that, I'll ask one question to you. If assertion, if electric field lines are parallel, then it represents uniform electric field. Then it represents, 1 minute, then it represents that electric field at any two random points is same, isn't it? If electric field lines are parallel, then it represents EA is equal to EB, isn't it? Reason tangent points in same direction. Options are option A means A is true, A is true, R is false. Option B, A is true, R is also true. Option C, A is false, R is true. Option D, A is false, R is also false. Tell me which option is correct. Uh, I think it's, think once again, then you tell me. It's saying that electric field lines are parallel, then it represents EA is equal to EB. Reason for that, tangent points in same direction. Does the reason satisfies this assertion, or both are false, or both are true? That's what I didn't have asked. The options like assertion is true, reason is also true, and reason is the correct explanation of it. I'm not giving you that options, just simply whether it is true or false. Uh-huh. Both are true. Confirm. So there comes an exception. See this. Let's suppose if I have these as field lines, which are non, means you can see that they are not parallel. They are basically not parallel, but the gap between each field length is totally constant or not. And then if I try to find out between A and B, you will find that electric field at A is similar to electric field at B, although the field lines are non-parallel. Yeah, because of this property that they have always a constant gap between them, and we call this as non-uniform electric field. Non-uniform electric field. But definitely at due non-uniform electric field, but not in terms of magnitude, in the terms of direction, due to direction. So the non-uniform electric field are of two types. One is non-uniform electric field with respect to direction and with respect to magnitude. Another one is non-uniform electric field is also possible when the magnitude is constant but there is a non-uniform direction. Are you able to get me or not? So of course, if electric field lines are parallel, then EA is exactly equal to EB, and reason tangent points in the same direction. So definitely EA can be equal to EB. But this is on also one case where tangents are not in the same direction, but EA is exactly equal to EB. So you said correct, both are true. Means A is true, B is also R is also true. But there is an exception in that. You should remember this. Are you able to get me or not? No, no, it should not be false because see. For assertion there is a reason, no. For assertion there is a reason. So we know that in the same direction the tangents will point. That's why their electric field are also same. So both are true actually. Why don't? But there is an exception that yes, there exists a non-uniform electric field due to the direction basis, and for that also the 2 points means EA is similar to EB over there. Are you able to get me or not? The tangents are not same for it. Still, A and R are true. Huh. A and R are true. Okay. Yeah, yeah. Okay. Let us do one more problem. Let's suppose I have two charges Q1 and Q2. Okay. And fill lines are drawn like this way. Got it? Now tell me, find the ratio of Q1 and Q2. No, find the ratio of Q1 with respect to Q2. Uh, you think you have to consider or not? Of course, when it is asking about ratio, you have to consider the positive and negative. So Q1 is positive, isn't it? And Q2 is negative. So you have to definitely consider positive and negative. Now, one thing you need to understand that right now I told you the number of electric field lines, the number is the amount, and that is equal to the magnitude of electric field, isn't it? So that means the number of electric field lines will tell about the magnitude of also charge or not. So let's suppose here Q1 is my positive charge, and for that the number of field lines are how much? 1, 2, 3, 4, 5, and 6. So 6 lines, isn't it? When I calculate for Q2, how many lines are coming? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So Q2 is my negative charge and it has how many lines? 16 lines. So therefore Q1 by Q2 is how much? Simple, 6 by minus 16. Right or not? Or you can minus 6 by 16, which is equal to how much? Minus 2, 3 is 6, 2 8 is minus 3 by 8. So ratio of Q1 by Q2 is how much? Minus 3 by 8. Are you able to get me or not? So every time the number of field lines will tell about the strength of electric field, and it will also tell about the strength of the coulomb of charge. Are you able to get me or not? Is this clear? So this was all about your electric field lines and their properties. There are many questions of these electric field lines which you will find on internet and all, and which you will be required to solve. Right or not? ठीक है? Sure. तो अपन क्या करने वाले हैं? अपन ने इलेक्ट्रिक फील्ड पढ़ ली, इलेक्ट्रिक फील्ड लाइंस पढ़ ली. Now I will be connecting these electric field lines with some questions and then we'll move ahead. Okay? समझो जरा. बोल रहा है कि there was a wall and with that I attach a thread. Okay, and with this thread the charge was hanging freely. Okay, the charge has plus q amount of charge and mass how much? M. Got it? And length of thread was L. Now suddenly I switch on an uniform electric field along the right direction. Take. Then question is, if charge is released from vertical, if charge is released from rest, find the angle, find the angle of a string with vertical, find the angle of a string with vertical in question number 1 at equilibrium, and question number 2 at extreme point. बताओ. सोचो, बहुत ही अच्छा क्वेश्चन है ये. फैंटास्टिक, वन ऑफ द बेस्ट क्वेश्चन यू कैन से. हो हो. चंदू के चाचा ने चंदू की चाची को चांदनी रात में चांदी के चम्मच से चटनी चढ़ाया. Those who are watching live, if you feel if there is any kind of doubt, you can ask me. If you don't feel any kind of doubt, then don't watch. So see, I'll explain this thing first. There are two things, equilibrium and extreme point, isn't it? थोड़ा थोड़ा सा समझ लेते हैं, एक छोटी सी बात मैं बता देता हूँ। जैसे मान लेते हैं एक स्प्रिंग है, स्प्रिंग से एक ब्लॉक को अटैच किया है ना, so then this block will be pulled by its own weight in the downward direction, isn't it? Now when it will be pulled back, you will see that there comes a point where the upward spring force exactly becomes equal to mg, and this is called as equilibrium point, isn't it? अच्छा, इस इक्विलिब्रियम पॉइंट पे तो एक दिक्कत है ना, एट दिस इक्विलिब्रियम पॉइंट द फोर्स हैज बिकम इक्वल टू mg because spring force was increasing and it was trying to dominate mg and it has become equal to over here, so here acceleration becomes zero, but till this point acceleration was in downward direction or not. So बहुत लोग सोचते हैं ना कि इक्विलिब्रियम पॉइंट पे वेलोसिटी की वैल्यू जीरो होगी, लेकिन एक्चुअली में एक्सेलरेशन यहाँ पे क्या कर रहा है, डिक्रीज, सो दिस वेलोसिटी इज non-zero. Velocity increases and it becomes maximum at equilibrium point in these particular cases when you try to apply some external force. Are you able to get me or not? And then as when it starts to come down off the equilibrium point, spring force starts to dominate, and when the spring force starts to dominate, the particular mg means the mg becomes less relevant, and here becomes my velocity to be equal to zero, which we also define it as extreme point. So many people think that equilibrium point means velocity to be zero. No, equilibrium point is that point where velocity is my maximum. Is that clear or not? Is that perfectly clear? So let's do our first question, first part of the question. Let us find what happens when this string comes to equilibrium point. So when the string will come to equilibrium point, what will happen? Can you tell me? So when this, okay, I'll tell you first thing first, that here the electric field will apply some force on this charged particle or not, which will throw my charged particle exactly over here. Control C, Control V, isn't it? And then this point will be some point which I can define it as इक्विलिब्रियम पॉइंट, इसको अपन डिफाइन करेंगे इक्विलिब्रियम पॉइंट, और इसको क्या डिफाइन करेंगे बालक, एक्सट्रीम पॉइंट, है ना। अच्छा, एक्सट्रीम पॉइंट पे वेलोसिटी क्या है, जीरो, इक्विलिब्रियम पॉइंट पे वेलोसिटी क्या है, नॉन जीरो. इज दैट क्लियर और नॉट? आर यू एबल टू गेट मी? Okay, so first we have to do the calculation of equilibrium, then we'll move to the calculation of extreme. So let us see that. ठीक है, this is my original diagram. Now try to understand the final case. Oh, 1 minute, sorry. The final case of the particle is over here. And this was my original vertical, isn't it? That's my wall, which is keeping the charges fixed. Okay. चलो, कोई बता पाएगा आंसर आया तुम्हारा कुछ? Can you tell me what will be the answer over here? So this is my vertical, this is my equilibrium point where velocity is non-zero. Okay, now over here we know that, oh sorry, let me erase this. This charge is experiencing a force due to electric field in this direction, which is given as F is equal to QE. And then this thread is also experiencing some tension in the upward direction. अरे होगा या नहीं होगा बताओ तो? होगा, yes. And this charge is also having some weight mg over here or not, है कि नहीं, है ना? अच्छा, दूसरी बात हम नोटिस करें तो यहाँ पे वेलोसिटी तो नॉन जीरो है, सो दिस चार्ज इज गेटिंग प्रोपेल्ड अलोंग द टेंजेंशियल डायरेक्शन विद सम velocity, and that is why this point is called as equilibrium point. Are you able to get me? Now, if it is a equilibrium point, then net force must be equal to zero, or net force will be zero when total upward force balances downward force, and total downward force should balances my upward force. But if there is velocity, then there will be also a presence of a centrifugal force or not. So that makes our calculation tedious, isn't it? So to ignore that calculation in a very good way, in a very professional way, we will do one thing. What is that? You can see that in this direction, I can resolve this QE and mg. ध्यान से देखना, तो अगर मान लो ये एंगल थीटा है तो ये एंगल क्या होगा? थीटा। तो mg का कौन सा कंपोनेंट इधर होगा? mg cos थीटा। और ये एंगल फिर से थीटा होगा तो f का एक और टर्म इधर आ जाएगा which will be equal to how much? QE cos थीटा। Are you able to get me or not? अरे कुछ तो बोलो यार, हाँ या ना? अब ध्यान से देखो, इक्विलिब्रियम पॉइंट है ना, कौन सी पॉइंट है? कौन सी पॉइंट है? इक्विलिब्रियम पॉइंट। तो एक बात बताओ, इक्विलिब्रियम पॉइंट का मतलब क्या होता है? यहाँ पर तो सारे पहले नेट फोर्स कितने होंगे? जीरो। तो अगर नेट फोर्स जीरो, अच्छा हम इसको ऐसे भी तो सॉल्व कर सकते हैं ना, इसको इतना टीडियस क्यों बनाओ? आई कैन सॉल्व इट इजिली। हाँ, मैं टेंशन को रिजॉल्व कर दूंगा, है कि नहीं? दैट्स इजी ना। लेट अस जस्ट रिजॉल्व टेंशन. So let's suppose if this angle is theta, this angle is also how much? Theta. So this will be how much? T cos theta, and this will be T sin theta, isn't it? And if f net is 0, that means T cos theta must be equal to how much? mg. And T sin theta QE. और इसको जब हम रेशियो निकालेंगे तो क्या आएगा? That means tan theta is equal to QE by how much? mg. So what is my vertical angle at equilibrium case? Theta is equal to tan inverse QE by mg. Are able to get me on? So this is when this means when this angle is created, when my particular angle over here is present at the equilibrium point, but my velocity is non-zero over here. Are you able to get me or not? Velocity is non-zero. Now see, this answer which we have brought is perfect for saying that we have brought the answer, but actually the point is, to talk about equilibrium point, we should not only take force net to be zero. For equilibrium point, there is one thing which is also zero, which we call it as that torque net should be also zero. Are you able to get me or not? For any equilibrium point, what is also zero? Net torque. Are you able to get me? Is that clear? What is zero? Net torque is also zero. Is that clear or not? Why I am saying this? Why I am saying this? There is a logical reason for that. Because since this velocity is non-zero, this velocity will have some component. This velocity will generate a radial force away from the charge, which we call it as mv square, isn't it? Mv square by r, which is mv square by l will be also present. The fourth force will be present, isn't it? But we just took an exception and we did through f net equal to 0 by upward force is equal to downward force. But in reality, there is a presence of centrifugal force also. So in during that case, whenever you solve the equilibrium point calculation, solve always using torque net, because you might not be always correct. So if torque net is 0, remember that. Let's suppose मैंने मान लिया ये एक point है origin. तो torque net through O should be also how much? 0. If it is which kind of a, if it is which kind of equilibrium? Normal equilibrium, or whichever equilibrium it is we are saying. Are able to get me? Now look over here, the length of the thread is how much? L. ध्यान से देखो, इसको मैं सॉल्व करता हूँ, सिंपल सी बात है. अपने पास ऐसे ऐसा एक फोर्स है और एक ऐसा फोर्स है ना, है कि नहीं? और ये अपन का ओरिजिन है, ये लेंथ ऑफ द थ्रेड एल है, ये टेंशन टी है, ये क्यू वी है, और ये क्या है, एम जी, एंड दिस एंगल इज हाउ मच एंगल, कुछ तो बोलो, दिस एंगल इज हाउ मच एंगल थीटा, है कि नहीं। तो अपने पास अगर ध्यान से देखें तो अगर एल मालूम है तो इसके ऊपर अगर अपने को परपेंडिकुलर फोर्स पता है, इफ आई कैन ड्रॉ दिस परपेंडिकुलर फोर्स on this length, then I can easily calculate the torque or not. We know that this angle is theta. So what will be the component of QE along that side? QE cos theta. कुछ तो बोलो यार, हाँ या ना। और और इधर क्या होगा, अगर ध्यान से देखें तो हमें मालूम है सर कि अगर आप इसको ऐसे रिजॉल्व करोगे इस डायरेक्शन में, तो ये जो, सॉरी 1 मिनट, दिस एंगल इज ऑल्सो हाउ मच थीटा, तो mg का इधर का कॉम्पोनेंट क्या होगा, mg साइन थीटा। अगर टॉर्क नेट जीरो है तो देखो टेंशन और लेंथ के बीच में क्या है, एंगल 0 डिग्री, तो टॉर्क ड्यू टू टेंशन इज हाउ मच, 0, है कि नहीं, प्लस टॉर्क ड्यू टू दो अदर परपेंडिकुलर फोर्सेस की वजह से आएगा, क्यू ई कॉस थीटा इनटू लेंथ एल विच इज ट्राइंग टू रोटेट इन विच डायरेक्शन, एंटी क्लॉकवाइज डायरेक्शन, किस डायरेक्शन में रोटेट करा रहा है बेटा, एंटी क्लॉकवाइज, प्लस एम जी साइन थीटा इनटू लेंथ एल which is trying to rotate in which direction, clockwise direction, अरे कुछ तो बोलो हाँ या ना, and that must be equal to how much, 0, तो इक्वेशन क्या आएगा, ये सिंपल एंटी क्लॉकवाइज विल बी इक्वल टू क्लॉकवाइज, सो क्यू वी cos थीटा into length L is equal to mg sin theta into length L, और एल एल कैंसिल, तो ध्यान से देखो वन सेकेंड, tan थीटा इज इक्वल टू क्या आया, क्यू वी बाई एम जी, एंड दिस इज द करेक्ट प्रोसीजर एक्चुअली, दिस इज द परफेक्ट प्रोसीजर. We are getting the same answer, but this is the correct procedure, that whenever you are finding the equilibrium in case of a rotation, you should make torque net to be equal to 0. Are you able to get me or not? Not the net force to be equal to 0. Is that clear? Because here velocity is not 0. Here there is an extra term of centrifugal force which is present over here. Is this clear? So although we get the answer with this F net, which is equal to theta equal to tan inverse QE by mg, but this is totally an incorrect procedure. Which kind of a procedure? Incorrect, to find the equilibrium. Are you able to get me? Is this clear? So how you are going to do to find the equilibrium? Follow mv square by r, sorry, follow torque net formula. Net torque should be 0 for any kind of a origin if my body is in perfect equilibrium and the body is rotating in nature. Now do the second question by yourself. Find the angle of the string made by the vertical at extreme point. Okay, do that question. That is easy. Now remember, so I give you two conclusions. I am writing that for equilibrium here, here velocity was not equal to 0. So applying F net equal to 0 without considering centrifugal force is a incorrect procedure. ठीक है? Okay, so do the question, do the case for the extreme point. Acha, at extreme point we know that velocity is how much? Zero. At extreme point, velocity of the particle is always how much? Zero. Now this is very easy. But many people will think that extreme point, if I want to find the angle for the extreme point, we can use normal formulas like QB or mg or balance that. But that is not true, isn't it? See, ध्यान से देखो, इसमें इतने इतने में तो बनेगा नहीं, एक पेज ही लेना पड़ेगा। देखो, तो अपन के पास पार्टिकल था बेटा, है ना? समझना अच्छे से, बहुत अच्छी चीजें आज मैं समझा रहा हूँ। ओके, पता नहीं कैसे मजा आ रहा है मेरे को पढ़ाने में। ध्यान से देखते हैं। तो ये इसका वर्टिकल पॉइंट था, isn't it? And my charge was kept over here. Now it went to extreme point, not equilibrium point. Okay, and at extreme point the velocity is zero. At extreme point, what is my velocity? Zero. This is q, and mass was how much? M. Q, mass was how much? M. So many people will think, sir, once again I'll apply T cos theta, T tan theta, and all those things, and I'll get the answer. Baba, at extreme point, we at extreme point we do not know that net force is zero. Are you able to get me or not? So you can't apply, you can't just means at extreme point पे ऐसे ले लिया, यहाँ पे टेंशन ले लिया, यहाँ पे mg ले ली, और यहाँ पे qb ले ली और बैलेंस कर दी, तो वो आंसर इनकरेक्ट है। क्यों इनकरेक्ट है? क्योंकि एक्सट्रीम पॉइंट के ऊपर हमें पता ही नहीं कि फोर्स इक्वल है या नहीं, वो तो हाँ, बिकॉज एट इक्विलिब्रियम नेट फोर्स जीरो होता है, एक्सट्रीम पॉइंट पे थोड़ी ना होता है। इज दैट क्लियर और नॉट? So then the question arises now, how you are going to solve? So remember that for extreme cases, for extreme point calculations, use only work energy theorem. आज दिमाग की बत्ती खुल गई होगी। मैंने बोला था ना, स्टेबिलिटी का सबसे एक अच्छा क्वेश्चन पूछूंगा बाद में जाके, सबसे लास्ट में, है ना? And this is that last question, that in equilibrium we can balance, we can still write force net equal to zero and torque net equal to zero, and we can do all these calculations. But in extreme point we can't apply those equations. Why? Because velocity is zero, force is not equal to zero. So how to solve it? We must apply work energy theorem to solve that. Is that clear or not? So let's suppose this is theta of extreme point, theta e, this is length L, and this is also length L, isn't it? This is length L, and this is also how much? Length L. So can I just construct a right angle triangle over here? Then this length will be how much? L cos theta, isn't it? This length from here to here will be how much? L cos theta. So how much height this particle has raised up when it is going from the normal case over here? Let me just draw that diagram of electric field. Okay, when it was present at t is equal to 0 over here, and it has came to this extreme point. So this charged particle has risen up by a height of how much? L minus of L cos theta, isn't it? So now I can directly apply now work energy theorem. What does work energy theorem says? Now we know that here the forces acting on the particle is, first one is tension, second one is mg, and third one is qe, isn't it? Tension, qe, and then mg. Isn't these all forces are conservative in nature? All forces are conservative. So इसका मतलब क्या हुआ? Simply I can directly apply the work energy theorem of conservative forces. That what is the work energy theorem of conservative forces? That work, simple, it is exactly we can write kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. This is only for which kind of forces? Conservative forces, isn't it? Now look over here. Kinetic energy final कितना है? Extreme point पे velocity zero है तो kinetic energy final कितना हो गया? Zero. Potential energy final कितना हो जाएगा? कितना हाइट मैं इसको रेफरेंस पॉइंट मान रहा हूँ है ना, तो कितना हो गया? एम जी एल माइनस एल कॉस थीटा. दिस इज द हाइट राइज्ड अप बाय द पार्टिकल, इजंट इट? एंड दैट मस्ट बी इक्वल टू काइनेटिक एनर्जी इनिशियली तो यहाँ पे रेस्ट पे है ना, जीरो, और प्लस वंस अगेन what if this is my reference point, what is this value of potential energy? Zero. Are you able to get me or not? So equation is how much? mgl minus mgl cos theta is equal to 0, or mgl is equal to mgl cos theta, and cos theta is equal to क्या लिखेंगे? अच्छा मैं एक चीज भूल गया, सॉरी. वाह 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 वाह, इसमें एक चीज इंक्लूड करना भूल गया मैं, दैट इलेक्ट्रिक फील्ड का भी तो एक वर्क होगा ना. सॉरी सॉरी सॉरी, बच्चे की लोगे जान क्या. Oh shit, I forgot that there is a electric field also. So now I'll have to use work done is equal to change in kinetic energy, isn't it? And work done is what? Work done, I'll have to write the work done by electric field plus work done by tension plus work done by mg, and that is equal to change in kinetic energy. But change in kinetic energy क्या होगा? जीरो, क्योंकि यहाँ पर वेलोसिटी क्या है? जीरो, और एक्सट्रीम पॉइंट पे भी वेलोसिटी क्या है? जीरो. सो चेंज इन काइनेटिक एनर्जी इक्वल टू हाउ मच? जीरो. वर्क डन बाय इलेक्ट्रिक फील्ड. अच्छा ये जो इलेक्ट्रिक फील्ड है, this is in this direction and it is throwing my charged particle till this displacement only or not? Till extreme point. So this displacement is how much? L sin theta. तो वर्क डन बाय इलेक्ट्रिक फील्ड क्या होगा? फोर्स बाय इलेक्ट्रिक फील्ड विच इज क्यू ई इंटू डिस्प्लेसमेंट एल साइन थीटा. दैट्स माय वर्क डन बाय द इलेक्ट्रिक फील्ड. वर्क डन बाय टेंशन, displacement is always perpendicular to it, this tension is always perpendicular to displacement, so work done by tension is zero. Work done by mg is change in potential energy because mg is a conservative force, isn't it? तो वर्क डन बाय mg क्या होगा? चेंज इन पोटेंशियल एनर्जी, नेगेटिव ऑफ चेंज इन पोटेंशियल एनर्जी, which is exactly equal to zero. So equation आएगा q e l sin theta plus zero plus negative of change in potential energy, 1 मिनट, जीरो हटा दो, माइनस फाइनल पोटेंशियल एनर्जी क्या है बेटा? एम जी एल इंटू कितना राइज कर रहा है? एम जी एल माइनस एल कॉस थीटा माइनस जीरो इज इक्वल टू, बिकॉज इनिशियल पोटेंशियल एनर्जी यहाँ पे क्या है? जीरो. ये रेफरेंस पॉइंट है, तो इक्वेशन आएगा फिर क्यू वी एल साइन थीटा इज इक्वल टू एम जी एल कॉमन ले लो, 1 माइनस cos theta. Are you able to get me or not? So ध्यान से देखो, एल एल कैंसिल, इक्वेशन आएगा क्यू वी बाई एम जी इज इक्वल टू 1 माइनस कॉस थीटा. 1 माइनस कॉस थीटा का फॉर्मूला होता है, इट इज 2 साइन स्क्वायर थीटा बाई 2, यही होता है ना, डिवाइडेड बाई साइन थीटा. तो इक्वेशन क्या है तुम्हारे पास? क्यू वी बाई एम जी, या इसी में कर लेते हैं. It will come as QE by mg is equal to 2 sin square theta by 2 divided by sin theta को लिख सकते हैं 2 sin theta by 2 cos theta by 2, isn't it? तो sin theta by 2 sin theta by 2 कैंसिल हो गया, 2 2 कैंसिल, तो इक्वेशन आया QE by mg is equal to tan theta by 2. Are you able to get me or not? तो एंगल कितना आएगा? थीटा बराबर ट्वाइस ऑफ tan इनवर्स QE by mg. इक्विलिब्रियम का वर्टिकल के साथ एंगल कितना था? थीटा इज इक्वल टू, दिस इज थीटा ऑफ इक्विलिब्रियम, ओके. and that is theta of extreme point. And you see that theta of equilibrium is exactly equal to 2 times, sorry, क्या मैं लिख रहा हूँ, theta of extreme point mean angle subtended with respect to vertical for extreme point is exactly equal to 2 times angle subtended for theta at equilibrium. यही तो होना चाहिए ना बेसिकली, है कि नहीं? जितना दूर तुम इक्विलिब्रियम पर जा रहे हो उसका डबल तुम्हें कहाँ जाना होगा, एक्सट्रीम पॉइंट पर. इज दिस क्लियर और नॉट? So that's why I did this question. Whenever you find that you need to find the angle subtended with respect to extreme point, what you need to follow? You need to follow work energy theorem. And when you are required to find, in this case specifically, when an external force is present, which is E, which is trying to push the electric charge towards right hand side, you always should follow the torque to be equal to 0, such that to find my angle subtended for the equilibrium point. Is that clear or not? Are you able to get me? मजा आया? Yeah, you have to always consider work energy theorem. ठीक है? चलो एक और क्वेश्चन दूं. कंफर्म बोल रहा है. या फिर इसको चार्ज डिस्ट्रीब्यूशन बता के ही बताना पड़ेगा. ओके, इफ दिस इज अ यूनिफॉर्म रॉड. चलो एक क्वेश्चन कर ही लेते हैं. बोल रहा है कि there are two charged particles. ओके. अच्छा, मैंने ये टाइम पीरियड ऑफ ऑसिलेशन वाला किया था ना, एसएसएम वाला, हॉरिजॉन्टल केस एंड वर्टिकल केस. लेट मी चेक. हाँ, if this charge is oscillated horizontally, हाँ, it's been done actually. Okay, तो एक काम करते हैं. Let us stop it till over here, and tomorrow we will start discussing the particular. Let me just delete it. Tomorrow we will start with the electric charge distribution of different cases, and then we'll move ahead. Is that clear or not? ठीक है. तब तक के लिए टाटा बाय बाय एंड see you.